All right, so this is the second problem, and it's the baby walker problem. And I'm just gonna tell you, I think of baby walkers as being like social distancing for babies, because what this is, it's a device. I don't know if you remember them. They're shaped kind of like a donut, and the baby sits in the middle, and then they walk around the room. So the baby, it's like shaped like a donut. The baby's in the middle, and they walk around the room on rollers, et cetera, and they have a tray around them. And I was thinking that if we all had we could all have like our own walkers that had like a 6-foot diameter circle, and that way we could all social distance. And so that's kind of what made me think of when I thought of this problem. Which is part of the reason you got stuck with it, because I thought of social distance. So baby walkers are seats hanging from frames that allow babies to sit upright with their legs dangling and their feet touching the floor. Walkers have wheels on their legs that allow the infant to propel the walker around the house long before he or she can walk or even crawl. Typically, babies use walkers between the ages of 4 months and 11 months. Because most walkers have tray tables in the front that block babies' views of their feet, child psychologists have begun to question whether walkers affect infants' cognitive development. One study compared mental skills of a random sample of those who used walkers with a random sample who never used walkers. Mental skills averaged 113 for 54 babies who used walkers with a standard deviation of 12, and 123 for 55 babies who did not use walkers with a standard deviation of 15. All right, the very fact that they gave me a standard deviation tells me I'm probably working with means. Now there's actual more evidence that I'm working with means in a moment. But this initially says, hey, you know what? We have a standard deviation, probably going to be working with some sort of test for means. And then it says, is there evidence that the mean, oh, there's that word that I was looking for, mental score of babies who use walkers is different from the mean mental score of babies who do not use walkers? Explain your answer. So right there they say, hey, you know what? We're looking to find out, are babies without walkers doing, is it different than babies with walkers? And I know they're not looking for greater, they're saying is different. So mu1 equals mu2, or mu1 does not equal mu2 for the difference. Mu1 is true population mean mental score for babies who use a walker, and mu2 the true population mean mental score for babies who do not use the walker. All right, conditions. We need random sample, and we have 2 random samples, one of 54 and one of 55. Independence. Groups of babies using walkers is independent of those that don't. That's a reasonable assumption. I know I'm having to assume that, but that's reasonable. They're separate groups. And if I'd said two independent random samples, that would have covered me. I need to make sure my sample size is less than 10%. So 54 divided by 0.1 is 540. So there are more than 540 babies who use walkers. And then also I know there's more than 550 babies who don't use walkers, because there's lots of babies. I do not have to worry about normality because, well, I do, I need to address it, but because my sample size is greater than 30, it's large enough in both cases to say it's by central limit theorem. It's normal enough by central limit theorem. So then I go ahead and I record and by the way, if you have a way of combining those 2 groups together, as long as you address both groups, that's fine. You can say 2 independent random samples of 54 and 55 are given. Groups are independent, and both sample sizes, if you address them together, that's fine. So you don't have to separate them just the way I did, but those are the conditions and they need to be addressed for both groups. All right, so our formula. Don't know what to tell you there, but we have the sample mean of those who used the walker minus those who didn't, standard deviation, those who used the walker, standard deviation of those who didn't. Degrees of freedom, we'll come back to that because that looks like I pulled it out of the air and actually just grabbed it straight from the calculator. I ran the test to get it. So what I need to do is I actually need to run this test to get the degrees of freedom. So stats test, And this is a 2-sample T because we're working with means. And my first one is 113. My standard deviation is 12. And my sample size is 54. 123 is my mean for the ones who didn't use the walker, with a standard deviation of 15 and a sample size of 55. Oops. And we want to know if there's a difference, so not equal. And we never pool when we're working with means. All right, so I get a T statistic of 3.84. Notice I doubled it. I wrote 2 times it because it's a two-tailed test. All right. And the calculator does the doubling for me automatically as far as a probability, but I just need to put the 2 there. So my probability is 0.0002. And please note, this is where I got my degrees of freedom from. All right, that's how it came straight off the calculator. All right, so our p-value is really small, and it's definitely less than alpha. We reject the null. So our p-value is 0.002. We reject the null. There's sufficient evidence at alpha equal 0.05 to suggest that there is a difference in the true proportion of mean mental scores for baby who used a walker versus those who did not. Great. So use a walker. According to this, there is definitely association between a lower mental score and using a walker. Suppose that a study using this design found a statistically significant result. We did. Would it be reasonable to consider that using a walker causes a change in mean mental score? Explain your answer. And the answer is no, because this was an observational study. This was not an experiment. So even though the results of the study are statistically significant and show a relationship between mental scores and use of baby walkers, the study is an observational study and is not an experiment. Therefore, we cannot claim that using a walker causes a change in mental score. So yes, there's an association. Yes, it was statistically significant, but no, we cannot say that it is causative because it was not an experiment. Zoom recording. So as I was saying, that was the entire question that was given on the test question, but I went beyond it and said create a 99% confidence interval for the mean study and interpret your findings. Well, I've just copied this over from the previous page. Conditions were checked, see part A, and I already talked about how to do the degrees of freedom. So I didn't feel like we needed to redo any of the work. I just wanted to go ahead and run that confidence interval so that we have an experience of doing that. So in this case, once again, walkers minus those without walkers. I have to calculate my T star, so I need to do that real quickly. Second vars, inverse T. And I wanted a 99% interval. So parenthesis 1 minus 0.99 divided by 2, degrees of freedom 102.83. And I end up getting a T star value. Wow, that's nice. I did not replace this. Should have been 2.624. All right, so that's my T star value. And then I'm going to go ahead and run this test. So stat test 2-sample T interval. And my mean mental score for baby walkers was 113. My standard deviation was 12 out of a sample size of 54. These were the non-walkers. Standard deviation of 15. Sample size 55. Confidence level of 99. We never pool when we're working with means. And I end up getting a negative interval. So negative 16.82 to negative 3.178. So we are 99% confident that the true population difference in mean mental score for babies who use a walker minus those who didn't lies within the interval this. Now, I find that this is statistically significant. Why? 0 does not lie within the interval. So 0 does not lie within the interval, which means that on average, the confidence interval indicates those babies who used the walker had lower mean mental scores than those who didn't. Now, it didn't say it caused it. It just means that they had it. So there was an association. We can't say it caused it. So this is, again, this is not an experiment, so we cannot say that walkers cause lower mental scores. However, we can say that walkers are associated with lower mental scores. So association is totally different than causation. We can make that statement that they're associated, but we cannot say that it caused it. And then lastly, interpret the meaning of the 99% confidence level in the context of the study. Well, if I were to do this over and over again or in repeated sampling, I think my method is great. And so I would expect it to capture the true population mean differences in mental scores for babies that used a walker minus those that didn't 99% of the time. In other words, the thing is so great that it works 99% of the time. So in conclusion, obviously, if you used a walker, your parents really didn't love you, and everything is their fault. Of course, then there's my story. Hey, Mom, did my brother use a walker? My mom replied in her loving voice, oh, no, honey, your brother was real smart, but you did. I'm supposed to be a little bit humorous.